So in this very first example we're going to graph the hyperbola given by the equation. And for a few of them, because we're going to graph like 5 of them, okay? We'll find, all the information so you guys can get the practice. Some of them I'll just say, it's graph. Do not find everything. But for this one, what is the center of this hyperbola?
0, 0.
It's 0, 0. And you know that because there's nothing, added to or subtracted from the x and the y, right? So the center is 0, 0. Now, is this going to be a horizontal hyperbola where it opens left and right, or is it going to be a vertical one?
Vertical.
And how do you know? The y starts first. More specifically, the x's are being subtracted. Okay, so it's definitely going to be one that opens up and opens down. Okay? What's a squared? 9. No matter what, for a hyperbola, a squared is always first, b squared is always second. So b squared equals 25, which means that a is what value? 3 and b is 5. Awesome, awesome. Okay? And while we're at it, let's go ahead and let's find c. Okay? The relationship between a, b, and c is normal Pythagorean theorem. So when we plug in, we'll have 9 plus 25, which is what? What's 9 plus 25?
24.
So c is going to be equal to square root of 34, which is about what? 5.8. Okay? That's okay so far, right? Okay. All right. So we know it's vertical. We know the center. Where are my vertices going to be located? Where are my vertices going to be located?
3, 0.
Careful. That's my foci. My vertices are located at 0, 3 and 0, negative 3. Now we could use the formula from the previous page to get that. Or if you think about it, the center's at 0, 0, A still works the same way that it did with the vertices of the ellipse. You just go 3 up from the center, 3 down from the center, since it's a vertical, and you got your vertices. So that still works the same way. Your graph goes by 2s, watch your scale. Okay? So there are my vertices. We already know there's going to be opening up and opening down. Okay? Vertices, where are my foci located? 0, 5.83 and 0, negative 5.83. Okay, if you haven't noticed this one, we're going to do all the goods. 5.83, negative 5.83. Okay. Foci is still on the inside of the branches, just like it was on the inside of the ellipse, on the inside of the parabola. That has not changed. Last thing, what are the equations of my asymptotes? Because this is important. It's going to help me actually graph my hyperbola. My asymptotes. It's going to be y minus k, so basically y equals the positive or negative b over a. So it's going to be, oh, it's a over b? Because it's vertical. So it's going to be 3 over 5 and then x minus h. So it's just going to be x. So I have 2 asymptotes. I'm going to have y equals 3 over 5x and y equals negative 3 over 5x. Now, we don't know how to graph lines, and guys, I really don't know. Come, we can do this. Rise over run, exactly. Okay? We can always base it off of, old school. It's going to be, you can always get in the slope-intercept form, do it that way. Or we can cheat, and it works this way every time. Start at your center. Because the asymptotes have to go through the center, so that's the main point. And then just do the slope. Okay? So 1 is going to be a positive 3, so up 3 and over 5. So up 3, 1, 2, 3, over 5. 1, 2, 3, 4, 5. Remember, my scale goes by 2s. That's why I'm kind of going like halfway in between. Up 3, over 5. 2, 3, 4, 5. Or I could go down 3 and over 5. And there's one of my asymptotes, drawn with dotted lines. Okay? Now I have to get my other one. I started my center. This time I'm going to go down 3 and to the right 5. Down 3, right 5, or up 3, left 5. And there are our asymptotes. Okay? So we can graph our asymptotes by just starting at the center, because that is the point that's going to be on our asymptotes, and just apply the slope, even for the more complicated asymptote equations. And then we just draw our branches. Okay? They get close, but they don't touch. Our vertices make sure they do go through. And voila, you have just graphed the hyperbola. Yes?
Do we have to make a table chart and have points like we did for Atlas?
Nope, we don't have to make a table or chart. We just need to make sure that we have our vertices in the right place and they approach the asymptotes. So the asymptotes are definitely very important here. Okay? Huh?
Do we have to do the square thing? That's just
Nope, you do not have to do the square thing. That's just to help you. Okay? But one thing that you can do, okay? You know that it's going to be 3 and 3, 5, 1, 2, 3, 4, 5, and 1, 2. And then there's your box. Okay? You don't have to draw it, but that's just another way to help you. Let's look at the next one. Okay? I want you to find all my information. Find my center, find my foci, my vertices, my equations of my asymptotes, if it's a vertical or horizontal, and then hold off on the graphing, and we'll come back together. Okay? What's the center?
-1,
Center is at -1 and -2. Is this horizontal or vertical? What's A?
3,
And B?
4.
So then I use that, or actually I use A squared and B squared. Tell me find C. C is 5. Okay. What else do I need?
Vertices.
All right.
2, -2.
2, negative.
Yeah.
And what?
-4,
-4, -2. So those are my vertices. Where are my foci?
4, -2.
And,
-6,
okay. What are my asymptotes? Okay. Well, if it's horizontal, you know it's going to be y minus k equals plus or minus b over a x minus h. So it's going to be y minus a -2, which is going to be plus, equals a plus or minus 4 over 3 x plus 1. Now again, yes, you can go ahead and distribute, get this into slope-intercept form, plot your slope-intercept, graph your asymptotes, or you can go from your center which is located at -1, -2, and apply your slope. I need a positive 4/3, so that means I'm going to go up 4, 1, 2, 3, 4, over 3, 1, 2, 3. Up 4, over 3. Or I could go down 4, over 3. There's 1. Probably not my straightest line, but there you go. Or again, I can start from my center and go down 4 over 3, or up 4 over 3. Honestly, oops, that's perfect. In my opinion, I feel like this is a little bit easier, okay? Because the center, again, is a point that's on your asymptote, so why not use that as your reference point and just apply the slope? We got our equation for our asymptote, so there we go. Okay? So again, this is my center. Now you guys said your vertices were located at 2, -2, and -4, -2. Well, I'm going to cheat a little bit, and I'm going to use my center and go 3 to the left and 3 to the right to see if you guys got the right ones. So 1, 2, 3. That is located at 2, -2, very good. And then go to the left 3. 1, 2, 3. And that's located at -4, -2. So yes, good. I don't know if you guys did that or used the formula, but there we go. Our foci is located at 4, 2. This is my foci. And -6, 2. -2. And I have everything I need. Gonna get close to the asymptotes, but not cross or touch. And there it is. You can leave it just like this. Okay? Now, this all happens to be multiple choice, and wherever I pull the multiple choice question from, and if they are in slope intercept form, hopefully you know just the history of using them. Subtract over. Alright? Now, if I ask you just to graph, not to find any information, honestly, all you really need are your vertices and your asymptotes. It's really all you need if I just ask you to graph, okay? And of course, determine if it opens up or down or left and right. Okay? And the center, because you got to figure out where your asymptotes intersect each other. So that's what I want you to do. I want you to just graph the next one. I want you to just graph the next one. Don't worry about all the extra information. Just graph this one. So just graph. We need the center. We need the asymptotes. And orientation. Okay? Where's the center? 2, 3. The order. We know that A is equal to what value? And B is equal to 4. So the equation of our asymptotes is going to be y minus 3 equals a plus or minus 5 over 4. X minus 2. Okay, so the slope of our asymptotes is going to be 5 over 4, positive and negative to graph our asymptotes. And this is open left and right or up and down? So it's vertical. Okay, so my center's at 2. Okay, I need to make this a little bigger because I'll do this every time. Okay, so I go 2, 3, 3. I apply my asymptote, which means I'm going to go up 5, 1, 2, 3, 4, 5, over 4, 1, 2, 3, 4, down 5, over 4. Again, I use my center, so I'm going to go down 5, right 4, up 5, right 4. Everybody okay? Oh, vertices. Dang, need those. Definitely. Okay? Alright? But not like I gotta use the formula. I just need to basically go from my center and go up. Is it 4 or 5? 5. The value of your A. Always. So up 5, 1, 2, 3, 4, 5. Down 5, there, okay? We all right? What we gotta do? We got to. What we gotta do?
We gotta factor out first.
We gotta complete the square, and we're gonna have to do some factoring out. Now be careful because this one does involve a negative. So when you factor out, you're factoring out a negative number, okay? Which means it's gonna change the inside, which is gonna affect your center. We're gonna go ahead and put this into standard form, and then we're just graph, okay? So we're gonna group our x's, just like before. Group our y's. As you see, the y is the negative. And already, if your coefficients are different signs, one's a positive, one's a negative, you already know automatically it's an ellipse. And then on top of that, you know since it's a negative y squared, this hyperbola, I keep saying ellipse, you already know it's going to be a hyperbola, and since the y is negative, you know that it's going to open left or right or up and down. If the y's are negative, it is horizontal, left and right. Okay? So we already know it's going to open left and right. So we're going to factor out a 25 from the first one, which leaves us with an x squared plus 4x plus a lot. And we're going to factor out a negative 16. And when we do that, when we take out a negative 16 from a positive 96, we get a minus 6y. Equals 444. We're going to add both of those blanks. Both sides. So let's complete the square. Half of 4 is?
2.
Squared is?
4.
4. Negative 6, half of that is?
Negative 3.
Squared.
9.
But what are we adding to the other side?
100.
100 and a negative 96. Okay?
Should be 144.
It's 144? Okay, that's all right. Okay. So we double check. All right? And now we are going to factor to get 25, then x plus 2 squared minus 16, y minus 3 squared equals, was 444 plus 100 minus 144. Divide 400 to both sides. We already know that this is an hyperbola, which means that we have to have it equal 1. What does 25 over 400 simplify down to be? 16. This one. And there's our standard form. We're just graphing here. So what's our center? Negative 2, positive 3. We already know that it opens horizontally. What are my asymptotes? It's going to be over A, so 5 over 4 plus or minus 5 over 4. What's K? It's going to be Y
Plus 3.
minus 3. Remember, it's Y minus K.
It's negative 3.
Yeah, that's in the general formula. So our center is still positive 3. So it's going to be Y minus 3 equals plus or minus 5 over 4 x minus x plus 2. And what's the value of A? A is 4, and B is 5. 4 is going to help us find our vertices. So, alright, so we got -2, +3. There's our center. My vertices are located 4 to the left and 4 to the right because it's horizontal. So 1, 2, 3, 4. Like I'm going by twos. 1, 2, 3. They're my vertices. Let's get these asymptotes in. I have to go up 5 over 4. So up 5. 1, 2, 3, 4, 5. 1, 2, 4. Or down 5, left 4. 1, 2, 3. Or go from my center and go down 5, right 4. Or up 5 and then back to the left 4. Drop my branches. All right. How do you feel about graphing?
The asymptotes are terrible.
What about finding information? Okay, we're gonna skip graphing the next one because I want to make sure that we can get to writing equations with different characteristics and then finding eccentricity. Okay. So remember, when we write our general equation, we basically need to know what h and k are, and we need to know what a squared and b squared are. So then that way we can plug into the formula. So in this particular problem, we are given that the vertices are located at -3, -6, and -3, +2. Your vertices will tell you which way this opens, okay? If my x's stay the same, but my y's are the ones that are different, is this a vertical or horizontal? It's going to be vertical, okay? So because the y's change, but the x's stay the same, we already know it's going to be vertical. So we already know that the y's are going to come first, and the x's are going to be subtracted. A squared is still first, b squared is second. Okay? So I already know this vertical. And remember, we can find the value of A by figuring out how far apart are the vertices. Okay? Huh? They're 8 units apart. So 8 is equal to 2a, just like before. That has not changed. Okay? That has not changed. So we divide by 2, a equals 4, and so that means that a squared is equal to 16. Your foci still help you find C. How far apart are your foci? 10. So 2c equals 10. C is 5. So c squared is 25. Just like before, that has not changed from ellipses. So this now means that we can use the relationship between a, b, and c to find b squared. But remember, unlike ellipses, it's a squared plus b squared. So b squared is what? 9. Cool. We got a squared and we got b squared. We find our center by doing what we did before. Either find the midpoint of the vertices or the midpoints of the foci. So either way, it really doesn't matter. We can always use the old school formula, or if you're the type of person that can just look at it and say, okay, I already know what's halfway between these numbers, I'm good. What's my x coordinate? -3. My y is going to be -2. So I have my equation. I'm going to write it right here in this box. Just be careful when you plug in. Y minus plus 2 because it was a negative over a squared, which was 16, minus x plus 3 squared over 9 equals 1. So really when it comes down to like finding your pieces, nothing really has changed too much with that, okay? Just gotta find, know what you're finding, okay? Let's look at the next one. We got vertices. This time we're given asymptotes, okay? But it's okay. Don't let that throw you off. We can do this. We can do this. Huh? It's going to be horizontal. Yep. So let me go ahead and write that down. It's going to be horizontal. Right. Can't keep up. It's horizontal. Oh, gotta be careful here. How far apart are my vertices?
6.
6. So we know 2a equals 6, which means a equals 3, and a squared equals 9. This is why I said be careful. Because it's horizontal, when you're looking at your equation of your asymptotes, is it a over b or b over a? For horizontal is b over a? Okay. So your slope for your asymptotes, you know all that extra stuff, plus or minus b over a. Now, we already know that b over a should equal what number? 2. Okay? Because if it's positive, it's going to be a positive 2. If it's negative, it's going to be a negative 2. We know that a is 3.
So just multiply 3 over 2, so b is 6.
So b is 6. You see how that works?
B squared is 36.
Okay? So we use the fact that we know the slope is b over a to help us find b, and we use the fact that we knew what a was because of our vertices that were given to us. So we have a squared, we have b squared. What's our center? What's our center?
Negative 6, 0.
Midpoint between these vertices. My center is at negative 6, 0. So here's my equation. X plus 6 squared over 9 minus y squared. You could put y minus 0 squared, it's fine. Over 36 equals 1. We're gonna do this next one. Okay? Some vocab here. The conjugate axis
Is the
is 2b. Very good. 2b equals 10, which means that b equals, and b squared is, and we're still given our vertices, which tell us what 2a equals. Wait, what's 2a equal? 4. So a equals, so a squared is 4.
It's vertical.
It is vertical because your y's are changing.
Your age. That's the same with the. And vertical is going to last us to be and lots of difference. It's going to be 2, 5, 3, 4.
What's our center?
3, 4.
3, 4. Midpoint between your vertices. So we have y minus 4, because k goes first, over 4, minus x minus 3 squared over 25 equals 1. That went a lot faster than mine. Write in these asymptotes, and I want you guys to find a squared, b squared, and h and k.
long as I've had.
So we were given the foci, which means we can find the value of c. So 2c equal 10. So c equal 5. So c squared equal 25. We actually could find a and b.
It's 3 over 5 did.
What is
B's 3. It's
b is
3,
3,
which is 9.
and a is
4.
4. Because since this is already given to you in that format, and asymptotes, horizontal or vertical?
Horizontal.
This is horizontal, which means that it's going to be b over a. So b is 3, a is 4, so b squared is, and a squared is 16. What's my center?
7, negative
7, negative 2. So it would have been
2. X minus 7 squared over 16. Minus 1 plus 2 squared.
all right.
So just like all the information. Then say horizontal, vertical.
Okay. They can't just give you like, okay, here's what you need to just the aim. You have to be able to see. All right. Eccentricity for hyperbola is the same formula as it was for the ellipse. What was the formula for eccentricity? E equals C over A. So that has not changed. But the eccentricity of a hyperbola tells you how uncircular it is, and will always be a number that's greater than 1. Okay? So it's still the same formula, but this time it's going to tell you how uncircular it is, meaning if it's like a flattened out branches, or they're going to be really, really tight curves, and it will always be greater than 1. The larger the eccentricity is, the more uncircular it is, meaning the more flattened out those branches are going to be.
That's all we do here.
It's the same thing that you did before.
Let's look at the denominator.
Look at the denominators, and remember which one comes first? A, and then B. So we have to use the relationship for hyperbolas. That is a 48, and that is a 36. So it's 84, so c squared equals 84, so c equals the square root of 84. No need to simplify it because it's going straight into a formula. It's a, which is the square root of 48. Be careful on how you type this in. You make sure you use those parentheses. You type it all in at the same time. So go ahead and do that. You guys get that? Very good. Very good, very good. I want you to do the next 2. Do the next 2. A squared is.
64.
B squared is. So you needed to use that to find c squared, which was the sum between the 2. So c was, so your eccentricity was 12 over, which is, what was it, over? And for the last one, a squared was 15, b squared was 75, c squared was the sum between the 2, which was 90. So if anything, if I were to compare these two hyperbola, the one in 4A would have been more circular than the one in 4B, because again, the bigger the eccentricity is, the more uncircular it is. Okay? Now for that word problem, get it in real fast. The path of a shadow passed by the tip of a sundial is usually a hyperbola. I don't know if y'all ever seen a sundial, but it basically, that's what they used to use in the old days to tell time. Okay? So, oh, you got one box timer? Cool. Alright, so write 2 equations of the hyperbola in standard form if the center is at the origin, 0, 0. Given that the path contains a transverse axis of 24 millimeters and one focus is 14 millimeters from the center. Whoa, okay, jumped a few steps. The transverse axis is equal to what? 2a. So that means that 24 equals 2a. A is 12, so a squared is 144. And it says that one focus is 14 millimeters from the center. Now remember, from the center to the focus equals what? It's 14, but what variable does it represent? C. So we know C equals 14, so C squared equals 196.
We should know our.
You should know your perfect squares.
Good job, I only got 24. Yeah, I picked 13.
And you've had me for how many years?
Not 3.
Exactly. I think I've been saying this since.
And every time you say it, I say you in a smile.
Alright, so we subtract over 144 to get 52. So we have our b squared, we have our a squared, and we already know our centers at 0, 0. So it says to write two equations. Well, do we know if this opens vertically or horizontally?
No.
So that's why it said to write 2. You write 1 where your x's are positive. And then you write 1 where your x's are negative. Because it said to write 2. Because we don't know if this hyperbola that's being formed by the sundial is going to open vertically or horizontally. That's why I said to write 2. Okay? And then it says to graph 1 the hyperbola. So you choose 1. And I want you to do that right now. Just graph the hyperbola. Your choice, whether you graph the horizontal or the vertical one. You said horizontal is your right? Horizontal is your right, right?
Yeah.
Yes.
So we know what sounds. I should put it away.
No, I still don't come out something nasty. What's square root of 52? So my center says 0, 0. I'm doing horizontal. So up 7 over 12. Down 7 over 12. My vertices are located 12 from